Hello everyone and welcome back to our channel. Today, we are diving into a super exciting and fundamental topic in Java programming, multithreading and concurrency. Have you ever wondered how your computer can do so many things at once, like playing music, browsing the internet, and downloading a file, all simultaneously? That magic is often powered by multithreading. In Java, multithreading allows your program to perform multiple tasks concurrently, meaning they appear to run at the same time. This is incredibly useful for creating responsive applications, improving performance, and handling complex operations efficiently. In this beginner-friendly tutorial, we will explore what threads are, how to create them using both the thread class and the runnable interface, and understand the basic benefits of concurrency. So, get ready to unlock the power of parallel execution in your Java applications. Imagine you are driving on a single-lane road. Only one car can pass at a time. Now, imagine a multi-lane highway. Many cars can drive simultaneously, making the journey much faster. In Java, a thread is like one of those cars on the highway. It is the smallest unit of execution that can be scheduled by the operating system. Think of your main Java program as one big task. When you introduce multithreading, you are essentially breaking that big task into smaller, independent subtasks, and each subtask can be run by its own thread. Each thread has its own call stack but shares the same memory space as other threads in the same process. This allows for efficient communication and data sharing, making your applications more responsive and powerful. Let us see how to create our very first thread by extending the thread class. While extending the thread class works perfectly, Java offers another, often preferred, way to create threads by implementing the runnable interface. Why is this preferred, you ask? Well, in Java, a class can only extend one other class. If your class already extends another class, you cannot extend thread directly. This is where runnable comes to the rescue. The runnable interface has a single method called run. You simply implement this run method with the code you want your thread to execute. Then, you create a thread object, passing your runnable implementation to its constructor. This approach provides much more flexibility because your class can still extend another class while also providing thread-specific logic. It promotes better separation of concerns, keeping your task definition distinct from the thread management itself. Let us look at a basic example of how to use the runnable interface. Now that we understand both extending thread and implementing runnable, let us put it all together with a practical example. We will create a simple counter application where multiple threads will try to increment a shared counter. This will demonstrate how threads work and also subtly introduce a common concurrency challenge. We will define a class that implements runnable containing a loop to increment a counter a certain number of times. Then, in our main method, we will create several instances of this runnable class, wrap each in a thread object, and start them. Observe how each thread executes its run method concurrently. You will see the threads running, printing their progress, and ultimately contributing to the final count. This example clearly illustrates how separate threads execute their tasks in parallel, making your program perform multiple operations at once. As we saw in our counter example, sometimes the final count might not be exactly what we expect. This brings us to a crucial concept in multithreading: race conditions. A race condition occurs when multiple threads try to access and modify a shared resource, like our counter, at the same time, leading to unpredictable and incorrect results. One thread might read the counter value, another thread might increment it, and then the first thread overwrites the incremented value with its old read value. This is a common mistake for beginners. The best practice to avoid race conditions is to ensure that only one thread can access a critical section of code at any given time. This is called thread synchronization. Java provides keywords like synchronized to help us achieve this, protecting our shared resources. Always remember to identify and protect shared data when working with multiple threads to ensure data integrity. Alright, we have covered a lot in our beginner's guide to Java multithreading and concurrency. Let us quickly recap the key points. We learned that multithreading allows your Java applications to perform multiple tasks concurrently, improving responsiveness and performance. We explored two primary ways to create threads: by extending the thread class and by implementing the more flexible runnable interface. We saw a practical example of threads working together, and we also touched upon the important concept of race conditions, understanding why protecting shared resources is absolutely vital in concurrent programming. Multithreading is a powerful tool, but it requires careful handling. The best way to master it is through practice. So, keep experimenting with different thread examples. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming tutorials. Happy coding, and see you in the next video.